Hi, this is Ask Dr. Ben. I'm Dr. Ben Newman. I study coronaviruses and I have done for over 20 years. So let's answer some questions based on the science, that's out there. So this one is from Kat, and hello again, Kat. Hi, Ben. Thanks for all that you and Nicola are doing. Sure. I read this article in The Atlantic was inspired by the idea of a simple spit test not too dissimilar to pregnancy tests. Yeah, those exist. And this will be a test for SARS coronavirus 2. There are actually different versions of this test, but let me read to the end and then we'll answer. Yeah, listen first, then talk. Why not? Do you think this article's on the right track about our way forward? And should I be buying shares in these companies? Yeah, you don't want to take investment advice from me. Yeah, I have no idea what any particular company is doing, but yeah, the idea makes sense. It's an idea that definitely could help dig us out of the hole that we're in. It would cost a lot of money, and right now I don't see any will from I don't know. Some state governors appear to have some will and are doing what they can, but it's not even most of the states, and there's nothing at the national level. There's no program that's really embracing the idea of testing the way it needs to be done, I think. So, yeah. So what the article is talking about, and I read the first half and then didn't read the second half. So if there was something amazing there, I missed it. It's talking about these things that are what they call lateral flow assays or sometimes rapid tests. Although rapid test can actually mean several different things. There are several different companies marketing actually totally different kinds of tests as rapid tests based on the fact that they can be done relatively quickly or they're more rapid than the other test. So the best test that we have is still the nasal swab and PCR, or rather the best test is the fecal swab. Not fecal swab, fecal sample, yeah, and then PCR. And everything else is not as sensitive, not as good at detecting the virus. Now, we don't know how many infected people the nasal swab test is missing. There are presumably some that have lower levels, below the level that it can detect. But it's the best test that we have, and so that's what we call the gold standard that we compare everything else against. The way these lateral flow tests work. So I think what they're talking about in here is something like an antigen test, which is a good idea. The idea is that you have an antibody, and so actually here it's a little Y-shaped thing, so we'll make a little Y. And the antibody is just a little protein with a particular shape that can grab exactly onto and only onto a virus. So there's our little virus. And so you're going to let the virus go past. You'll put some saliva or something on, and the saliva will be, or the water from it will be drawn up this little strip because, just by capillary action. Like when you get a little edge of a piece of paper wet and then the rest of it gets wet. It's just what the way the physics works. Okay, and so the virus is then going to flow past, and the virus is going to get caught on this first antibody. And if that happens, then you can come along and you'll have a second antibody that'll come along and grab onto it, and we'll have something on the end of that antibody. Usually it's just like a little speck of gold, and it'll look either sort of brownish or reddish in color, depending on how much there is. And if you get enough of those little specks lined up there, it will make a little line across the strip. That's exactly how pregnancy tests work. Little antibodies. So the antibodies are waiting, and then if the right thing flows past, they catch it, and then there's another detector that flows past as well, and that will latch on to the top. They work pretty well. None of them are as good as the PCR test, but they're really fast. You can run one of these things in 5 minutes and get a pretty good result. You don't even have to wait the full 15 minutes in my experience. And you can read out the amount with a little bit of clever physics, just by basically how dark the line is. And yeah, you can just do a ton of these things. The way they make them is they make a giant strip of paper and they just put those lines down, those little lines of antibodies on it, and they cut it into little strips that are just, it only has to be 1 or 2 millimeters wide, and loaded in a little plastic cartridge. And again, it doesn't really need the cartridge, but that's fine. And bam, yeah. The thing just works. So I think that is very much a way out of this. I don't know which way people are eventually going to go, whether it's going to be this one, but I feel like somewhere out there, at least one of these lateral flow assay things, maybe several of them, will end up being really useful. And will actually, when we get to the point where we're trying to test literally everybody in the US, and we have to get to that point to get over this virus, to get there, we are going to need rapid tests like these lateral flow assays, like these little pregnancy type tests. So yeah. I don't know. Yeah. In terms of investing, I have no idea. But in terms of the technology, yeah, it's scientifically sound. It's pretty good. It can be super mass produced. I wish we were super mass producing more and using more because, yeah, it's a potential way out of this that otherwise we would not have. I think the only downside to these is that they can be relatively insensitive unless you do something to open up the virus. So most of these antigen capture lateral flow assays are going to try to catch on to the one protein that sticks out from the virus, which is that spike protein again, the one that, the sign language coronavirus has sticking up, these little guys. On the best, like most precisely made coronavirus, there's about 80 of those that you can grab. On your average coronavirus, it's more like, 65, 70, something like that. And the thing is, you need a lot of little gold particles on there to be able to detect it by eye. Now, if you're trying to detect this with lasers, physics, computers, then yeah, you can bind fewer of those particles and you can actually potentially accurately read them out. But if you need enough to see by eye, you've got to have a whole lot of virus in there. But if you can open up the virus and look at the proteins inside, there are about 2,000 copies of a thing called the N protein. And that just gives you, 2 orders of magnitude better detection, for all the science type people out there. It makes it about 100 times easier to actually detect something, is what we're saying in regular people talk. So yeah, I like them. I like the idea. I don't know anything about the Atlantic, but in this case, that article is right. So there we go. Thanks very much. This is Ask Dr.